Welcome back, Gen Chem friends. Thank you for joining me again today as we continue a conversation on Chapter 9. And in this little vignette, we're going to tie together the concept of hybrid orbitals with Lewis dot structures and talk about hybridization. Well, now we've already mentioned that term hybridization with regards to mixing orbitals on the central atom and how those orbitals participate in bonding with outer atoms. In this chapter, or in this video, we're going to talk about how we use this hybridization nomenclature, if you will, regarding or with respect to the central atom of a molecule to say something about the geometry of that molecule. So if you remember when we talked about Lewis dot structures, after drawing a Lewis dot structure, you were able to find the VSEPR notation, and from that VSEPR notation, from that AXE notation, you are able to say something about the shape of that molecule or the geometry of that molecule. Well, it turns out that we can do something similar when looking at the hybridization of the central atom. Knowing what that hybridization is, or knowing what hybrid orbitals are used in that molecule, we can then determine not only electron pair geometry, which is what you will need to do for your online homework, but we can also link it to its molecular geometry. So this starred chart relates hybrid orbitals to the structure's central atom. And so if we were to say that if a particular molecule had a central atom that was sp3 hybridized, that should tell me that, oh yeah, that means that that central atom uses one s and 3 p orbitals to make those connections to outer atoms. And anything that is sp3 hybridized has to have 4 things attached to that atom, either lone pairs or bonded atoms, and that corresponds to a tetrahedral geometry. So this smaller chart just sort of summarizes that. In the next slide, I've just tried to illustrate that this number of structural pairs on the central atom is equal to the number of electron domains that's on your chart from the Chapter 8 PowerPoint, and it's also equal to the number of atomic orbitals used to form the hybrid orbitals. So if I have something that is linear, it has 2 electron pairs, either bonded or unbonded on the central atom, then that tells me that, oh, for hybridization, I'm going to have an S and a P, or an sp hybridization. So we can directly relate number of structural pairs on the central atom to the number of atomic orbitals that are used to form the hybrid orbitals. And I've tried to take this slide as well as the previous slide along with the slide, the chart that I gave you in Chapter 8 to summarize, and I know this is pretty busy, but what I have done here is everything should look familiar to you, hopefully, except for this last column. The first 1, 2, 3, 4, 5, 6 columns of this chart was given to you in Chapter 8, and it related the VSEPR notation of a molecule to its particular molecular or electron geometry. And I told you that for the exam, you just needed to memorize the molecular geometry and the corresponding VSEPR notation, or AXE notation. Now you just need to add one more thing to either your note card or however you are memorizing the information in these 2 chapters. You need to know that if something has a VSEPR notation of AX2, the geometry of that molecule is linear, and the hybrid orbitals that are involved in that molecule, meaning the hybrid orbitals that the central atom uses in that molecule, are sp hybridized. So these last 3 columns contain information that you do need to memorize. There is a little bit of a pattern. You see that for all of the VSEPR notations, depending upon how many electron domains you have, that will equal the number of hybrid orbitals. So, or that will equal the number of atomic orbitals used to create the hybrid orbital. So, for example, for AX2, I have 2 electron domains. So that means I need to have one s and one p atomic orbital mixed to give me an sp orbital. Species that have 3 electron domains, regardless if all 3 domains are bonded or if you have 2 bonded and 1 lone pair, both of these geometries have 3 electron domains, so they better have 3 orbitals that are available for bonding. And so to get 3 hybrid orbitals, you have to have 1 s and 2 p's to give you sp2. And then you can do something similar thought process with the remaining VSEPR notations and hybrid orbitals. So last 3 columns of this chart organizes the molecular geometry and VSEPR notation for a molecule based off of the Lewis dot structure. And then also says something about the hybridization or the hybrid orbitals that the central atom uses to make those connections to either the terminal atoms or the lone pair. So I would encourage you during working on your online homework, doing problems, working through problems that I have posted on the lecture Canvas page, or working through problems that we will talk about in my subsequent videos. I'd recommend having this chart in front of you because it will be necessary to help determine the orbitals and the geometry for a particular molecule.